Welcome, I'm Bill Wake. We're here working on a programming language compiler and interpreter for a language called Tenth that's kind of an imitator of Forth, which is a stack-based programming language. And we've done pretty much everything we intend to for numeric stuff, but we haven't dealt with strings yet. So what we'll do today is work on the strings. We have to worry about compile time and runtime, but quote, string, quote, we'll create a string and push an address on the stack. And then our string is going to be immutable. That means there'll be some extra copying sometimes. We'll just live with that. $$ is going to print the string that's pointed to. Split $, will break off the first character. Join $, will put two strings together. And make $, will convert an array to a string. So with those capabilities, I think you could do everything you need to do pretty reasonably. You might have a lot of more string stuff, you're right, but this will be a good starting point. All right, the second thing on that is we have strings at compile time, and I thought a little bit about this. I think what I want to do is make a little make an addition to the secondary, just like we do for numbers. We do pushes in on the data stack, and we want to make push the address of the string. So I don't have a good place to put the string other than in the secondary space, or we could make up a new space, but I think it's easier to just keep everything in secondary if it'll work. All right, so what I propose we're going to do is we'll do a push instruction followed by a secondary space pointer a few words down where the string is, and then we'll jump around the string and get back to the code down at the bottom. So the -1 is going to get patched once we get to the bottom and we know what the address is of the last word or the word after the string. And then the string, we'll put it in place after the jump, kind of mix our code and data segments, right? But put that after that. And then most strings we have to fill out to 64 bits. So because our instructions need to be on 64-bit boundaries, we need to make sure the string stuff is there too. So we have a routine that will do that. So I'm not too worried about creating it. But I think that'll give us the ability to put that in code. We won't make multiple copies as you execute. It'll just be sitting there. So I think that'll work reasonably well. All right, and then finally, no session tomorrow. I'm off tomorrow, but I'll be back Monday, April 8th. I didn't want to forget to tell you. All right. Now, I think just to be careful, because I always forget, let's just run all our tests. I'm getting quite a few, aren't we? Okay, so I'm not seeing any reds. I'm not seeing any weird crashes or anything like that. So good. All right. We want to deal with this. We'll start with the string constant first. I think we'll do that and then $, so you can print it, and then at least we can say you can do something with strings. Okay, so do we have a file for strings yet? I don't think we do. Oops. No. All right, let's do that first. String.s, we'll move it up a folder. Create that. And down here, okay, now string. Well, I don't really have any. What are we going to do first? I guess the real thing we want to do first is kind of like we did a number test. I don't know where we put that. Compile. Push : stack. All right, let's close things to the right. All right, pop removes an item, dope, swap, push 0, push 1 item. Okay, I think that's... All right, well, that's testing push, but it's not testing how it got there. Let's Close that. I think it really is going to be compile. No. Oh, it's not compiler part. It's the interpreter part. It's the runtime. Okay, I'll get there eventually. Interpret empty. Well, make sure the word is in here. Interpreter. Okay, I'm just in the wrong place today. Not compiler relation. Well, it's no. Maybe it is REPL. Let's look there. Well, that might be it. No. Yeah, I'll push his number on stack. Okay, that's the one. Strings quotation marks. Yeah, that's a good question. I think the easiest way. I mean, your toss-up is basically the SQL way where you double your quote marks to get quotes, or the C way where you do / quote. I don't feel strongly more like which one's the easiest, but let's save that problem for later. Let me add it to the to-do list though. How to put in strings. All right. So anyway, REPL tests. So what we've done is we put a string on the stack, and then we evaluated that. Okay. And that's the kind of thing we're going to do for strings. So let me just copy this. Actually, let's, what's going on here? That was weird. I lost it. If I'll push this number on data stack. Okay, so I guess it includes this. A little more white space than we need there. Okay. That should be dot. And we'll certainly need some of this stuff. I don't think we'll need dictionary. All right, I think I'm going to use the real stack for this. Let's do build data stack init. Push a string address. Okay. Now, I don't know how our assembler puts quote marks in. L string. Well, here's the two choices. Let's see what happens. Well, I don't have string in my make file yet. All right, and we need stack.o, and REPL is the val in there. Yeah. Okay, let's try the other way. Oh, did I? Make sure I had the right. It's got to be balanced. Okay. Let's hope this works. Test. Similar. I guess we need. These are probably. Okay, good. Right, so I'm not using this, so I don't need to worry about that. Okay, so it seemed to like this string okay, so string is now pointed to an eval. Let's do data pop x0. And that should give us the address of the string, which is exactly what we want. Let's make it more stringy though. A string space. And then L string expected ASCII Z a string space. Push the string address on stack. Oh, I need my test loop. Okay, let's do load address. X1 gets L string expected and assert equal strings. So whatever I pop off the stack should be a string pointer, and X1 is a string pointer, and those two strings should be equal. Excuse me, when we're done. Okay, I'll include the Unix stuff. Alrighty. Eval. No, this is string test.out. Referencing dictionary search from eval and REPL.o. Oh, eval wants everything. Okay. Let's see REPL tests in the make file. probably overkill, but looks like it needs a lot. Oh, really? Well, those are on arithmetic. We'll get there. Duplicate symbol start and string test.o. Oh, we don't want main.o. Okay, where's my string tests? String test.out. Okay, he's really string tests, but we'll fix that name. All right, blew up. Okay, well, that's kind of what we'd expect since we didn't do anything yet. Okay, let's fix the test name. Okay, and now let's get REPL up here. Okay, so REPL has two parts. It has you're basically in compile mode or run mode. Let's get up there. So eval all takes care of finding out which one you are. All right, let's get up to eval all. Okay, so it basically looks at I'm not sure now. It's looking if you're in compile mode or not. And then it asks, is meta? Let's see what is meta's doing. Well, there's the code I want to do, is this stuff. Okay, so we've read a word. I mean, we don't read. Okay, so read word doesn't know how to parse strings. Not sure what we're doing here. Okay, so we look up the thing in the dictionary we got back. It's not a dictionary word because it's a string. It's not numeric. And until now we do word not found, but we want to check for a string. Okay, so I don't know if let's see, read word. That's an IO. I don't think so. Or is it in REPL? Okay. Oh, yeah, I really didn't want to go back here. Okay. Because reading a word is kind of complicated. We're skipping over spaces, and we finally get to something that's not a space, so we know we're going to return something. Okay, so this gathers the next word, but I think we're going to have to say, hey, yeah, you're not a space, but are you a quote mark? And if you're a quote mark, we know we're going to enter a string. But I would say, well, this maybe should have a separate test for the reading of the word, reading the string. Input tests. All right, read with word start, read with multiple words, read from new line only. Okay. I'm going to put this other test on hold. And input tests. All right, so input tests, we're going to add a test for that. So BL read string. Okay, that's probably enough for starters. Excuse me. Okay. Let's see. So read. Well, there's read stub init. Loads an address and reads the string we're after. Okay, I guess those things are what we'll do. We certainly need to initialize it, and then let's add L simple string, let's say, and then ready. Okay, so that gives us a substitute read routine that we can plug in different strings to. So that's fine. And then L simple string. Let's see, where are those things? Okay, read sources down there. Okay, so we can put our string down here. L simple string, ASCII Z, quote back quote, quote back quote. I'm a string. Okay. Now this has put the word there, so let's see. Load address, read line routine, BL read word. Okay, I think I need to mark my tests. I've been doing this arrange act assert thing. This is really a series of those and then some asserts. Okay. All right. Well, we'll definitely need to do this. Okay. So we've got our stuff. We want to do a read word. Range. All right, and how will we know we got the right thing? Well, read word returns x0 with it. Okay, put it before the numeric check. It only needs to check the first byte. Yes, I think that's a good idea. All right, so what we should get back is really the string itself. All right, so x0, well, let's just assert. Let's move load address x1 is L simple string. And we want to see that x0 is the return string. And we want to do assert equal strings. Okay, so reading that should get us empty a string. Okay. Now, all right, I think that's a legitimate test. I might put a little more in the string. I mean, our read word, it skips spaces, leading spaces. I guess that's separate. We already know it does that, so I think we're okay. Find trailing space or new line. Wait. Check at end. Find word start. Skip over the spaces. If not a space, jump down to find word start. Jump back to find word start. Okay. Space. Set the return pointer to this word. Ugh, this is really not fun. Okay, I think if our test is legitimate, let's start with that. I think it is. Whether we could write a better test, well, I think this is about as simple as we want to go. Right, so let's make that. An input test should fail. Well, not quite that quickly. Input test.o, depending start of a token, colon. Macro definition. $195 test start. Okay. Oh yeah, you got to put a name. Okay. Read string. Wow, I'm just striking out here. Eval pushes string address. Right / BL. Line 59. Well, that's pretty early. 5859. Huh. It's complaining about BL eval pushes string address. Wait a minute, where's that? No, string tests back there. I see. Okay. Incompetent commenting. All right, string input should fail. Here we go. Oh, interesting. Okay, so it took the first set of characters up to the blank and then it stopped looking for a string. Okay, so I think we can work with that. And I think this name is probably needs to be longer too. So input tests. Instead of just read string, I think reads whole string. Maybe it's just reads whole string. Okay, I think that's a good name for it. All right, and it failed the comparison because we have a val, but it only knows about reading blocks of non-space characters. Okay, so now input. All right, so I have to kind of recover my head around what we were doing before, but do the prompt, that's fine. Do the reading. I guess read word is where it's at. Okay, so read the new lines if necessary. Okay. Now, I don't think string should carry over across lines. I think that'll just be too confusing, so we'll have to deal with that. Okay, So we find word start. It's not a space. We jump down here. Okay, I think we need to compare W0 to, and then I don't remember, double quotes, 34. ASCII codes. Quotes. Space is 32. Ha! Okay. Small pleasures in life here. Okay. Okay, if it's not equal to 34, then we're going to branch down here, which is just word start. All right. And then if it is a double quote, okay. Yeah, 22 is nice too. Okay. I think we need another word, another whole routine for this. So let's do that. Let's make read word. And then when you're done reading the word, we should go wherever you do after you finish one of these words. Okay, check if at end. I mean, this, find trailing. Zero A is new line. I should mention that here. New line. All right. So read word. Let's branch that there. And then when we finish a word, if it's not load byte next word, we compare the character. Do we need branch to check at end? That seems weird. Yeah, so I think it's got a whole vibe to it that's different, and I think if we pull this routine out, that'll be a step forward. I feel like maybe this is already plenty big, too big, really. Okay, because I can't find what I want to know instantly. So L word start seems like, okay, I've got the start of the word, and like somehow I have to loop, right? So I load the next byte, and if it's a new line, oh, I'm gonna fall here. Oh, okay, yeah. So I branch to this or that until I get new line or space. My quote is going to be till I get a quote, and then I want to exit space or new line. Well, I'm going to call this exit word. Store byte 0. Okay, so that's the ending of that word. That seems good. All right, so I think in the end, after it's gathered all its stuff, it says, okay, store a 0 byte and you're done. And basically you return. Okay, so I think we will branch to one exit word. And while I'm naming this, let's put the L on it. I think we had non-L words because we were debugging so much on this, which is not like good sign. Okay. Not a space. Okay, that's true. All right, so this is look for a string. And this is look for a regular word or number. Okay. Should auto terminate on a new line. Yeah, that may be reasonable. I mean, I think it's more likely to be a mistake, but it's not unreasonable. And I think that, okay, so this should be kind of refactoring territory. Yeah, what do I know? Exit space or NL. That was exit word, right? Right? Exit word reference from input init. Read word reference from input init and input.o. We're compiling arithmetic tests. Input init references exit word. Input.o. I don't see how it does. Read word reference for input init. That just seems. Oh no. I do have a reference to read string at this point, right? So wherever that got off to. Oh, this should be read string. Exit word without L prefix, line 96. Oh, you're. Oh. Yeah, you're right. L exit word. Something seems wrong though. Let's do a diff. L exit word. That seems okay. Well, let's make sure that's okay. Okay. All right, input tests. Read whole string, kaboom. Illegal instruction, yeah. Oh, we don't do anything. Let's just do a return. Might get an infinite loop. Nope. Okay. Segmentation fault. All right. Yeah. Okay. So I guess. All right. So this is going to be a lot like this stuff, but it's looking for different things. So we get find word start. This goes to not a space. I think I'm going to change this name to look for string. All right. And then if we had come here, L word start, let's take this as sort of a starting point. I think we're duplicating stuff. L word start. Well, this is going to need a prologue. Oh, no, it's not. We don't do any of that. Okay. And exit word. Okay, so we come in here. We know we've got a quote. X0 gets next word. That's the result value. Now, the one thing that's funny, like I don't want to include the quote. Okay, but we'll deal with that later. All right. Set the return to point to this word. Okay, that's fine. Load the byte at next word. Okay, so here we save the pointer, we load the character, which I would think we would already have loaded, right? Convert 0. Maybe we're just... Yeah, I'm not sure this is that helpful. Okay, so I'm gonna add x0 equals. Oh no, that's not gonna work. I mean, we really know at this point. We know we had a quote. I want to add 1 to x0. X0 gets next word. Well, that is a pointer, so I think I can say add. Add x0 is next word plus 1. Okay, so set the return to point to this word. I'm going to load that word, compare it to a new line. Yeah, I want to automatically skip the quote. And for now, I want to stop on the first quote. Okay, so I feel like I should just increment next word. I mean, this is just kind of suggestive stuff. I think the real thing is, okay, we got our return a value. What's the address we're going to return? Well, x0 is next word plus 1. Let's add x next word gets next word plus 1. Well, then I can just move this up. go back to the move. Okay, so I'm skipping past the quote. It probably doesn't hurt to say that. Skip past the first quote. All right. Now I'm in the body, and if I see either a quote or a new line, then I got to exit. We don't even put the 0 in because that's done at the end for us. We could decide it's worth it, but we just have to get our pointers ready to go. So up here, once it realizes it's past the thing, it stores the value in the word. I don't know if we're quite, I don't know. We'll have to see how this looks. Okay, so I certainly have to load the next word, right? And I'm going to compare it to new line. I think it's actually more similar to this down here. Let me just move this out of the way, because I'm not going to go read more words, so I don't need to check it in stuff. Let's call this L loop string. L exit string. Okay. So if I hit a new line, I'm going to stop. If I hit a quote, which is 34, okay, I'm going to go to exit, and then otherwise loop back. Okay, so let's see, I lost something here. Okay, so I'm going to read the next character. If it's a new line, I'm going to jump out. If it's a double quote, I'm going to jump out. And if it's not, I'm going to go back up here. So by the time I get out of this loop, I know I'm sitting in a character I don't want. You know, I'm almost inclined to not worry about new line at this point. All right, but here I am ready to exit this string finding thing. My next word is pointing to the first word I don't want, right? Or first character. So something seems wrong. Well, I think that's close. Let's see what we get. Okay, x0 equals. Oh, well, that's good. That's kind of what we want. Okay. That means my test is not really up to the job because we stripped off the quotes, and we need a version that shows that. I'm a string. Okay, which is actually kind of good. All right, make. Now, I feel like I'm worried about that new line. We haven't justified it. Okay, you don't want the quotation marks at the end. Yeah. Yep. So I think this does something. I would say we certainly haven't tested this stuff into existence, and I'm not necessarily convinced it's worth us doing it. All right. Let's leave a gap for that too. So, how to put quote in strings. What if strings don't end by end of line? Okay. I mean, those are two things I care about, but I'm kind of de-emphasizing. Well, I don't know. I don't want to get hung up on them. I guess I think there's a lot of possible weird conditions and things like that that we have to worry about. Mostly just end of line, I guess. But I'm worried that if we zero out the end of line character, like who's going to find the end of line when they go to find the next word? We've chewed it up, and so that seems like bad luck. And really, if we hit that, we really should probably. Well, I'm not sure what we should quite do, but maybe put a new one in, or I don't know. Something should happen that's unusual, and a lot of that's kind of a distraction from this. We have the simple case working. If you say quote and then a bunch of stuff that may have spaces in it, and then quote, it creates a string for that. Now that string is just sitting there in the input buffer at this point. So let's see, make sure I didn't mess things up. All right, where's input tests? Good. Okay, so I don't want to forget these things, but I feel like if we push forward on making the interpreter work and the other, then I think I think the progress will be better. It'll give us a mechanism we can use if we're careful. Okay, a little bit of a sharp knife. Okay, so now let's check this in. Make read word call read string and return a string from input. Okay, now I think we're ready to say eval has the responsibility. So input tests. This test read a whole string. Basically, did you put the address on the stack like we wanted you to? Okay. Oh, what happened there? Reads whole string. Did this test run? Oh, input tests. We want string tests. Yeah. Okay. This should fail. And it does. All right. I think that's progress. Okay, so now we're in eval. Here. And we looked up the word in the dictionary, which I think is the usual case. Strings are going to be relatively unusual. But now we can, let's see, X28 temp. Well, it's really the input word. Okay. So instead of check for numeric, let's put L check for string and change this. Okay. We'll move x0, x28, get the string back. I think we need to load byte w1 with x0. Okay, we're going to load that first character. Compare. Actually, let's see extend to the characters. Yeah, that's probably true. Let's. Okay. So compare W1 to 34, which is double quote. If it's not a string, then we want to go to del check for numeric. If it is a string, well, he's going to do the push. We're going to do something similar and then eval exiting. So branch to L, eval exiting. Okay. And well, so now we've isolated the string. I think we just don't push the stuff on the stack at this point. It still fails. At least I certainly hope. I keep looking at input instead of string tests. Yeah, probably that data pop or something else like that is not legit. Okay, and what do we want to do? Well, okay. This is where, well, it's that code we were looking at yesterday. So right now we have string in the input buffer. We want to move it. I forget where that stuff is. Oh, what file would that be? Not input. I guess dictionary? No, something about the header stuff. Yeah, where's make header? Make header. Variables? Define string. Yeah, this thing. Okay, so this is in a pile. String.s. REPL. Okay. So I think this is going to do it. We got a word we're pointing to, which is going to be our buffer. We put the word string after the last secondary, and then to that, we don't return. Okay, so I guess secondary space is the address we're looking for. Okay. REPL. x0, x28. Okay. So somehow we have to do the equivalent of this. EQ word not found, whatever, push x0. Okay, so for us, for string, we know it is a string. We need to do a string copy x0. X28 is the buffer. I don't want to lose track of where it ends up. Okay, I think we have to. Okay, we don't need the word anymore. Okay, we have to somehow hold secondary space because that's going to change. So I'm going to say move x28 gets secondary space. And then I'm going to say branch to define string. It's going to write the word in, adjust the stuff, set secondary space. That's all fine. All right, so BL define string. And then we need to push the address on the stack. Well, actually, we could do that here. So secondary space, it does get replaced. It's just done. Let's see, that was an input. So when it returns, it's returning back here where it comes down here and does that. So that's getting that 0. And you can tell because our test didn't print I'm a string extra quote mark, it printed I'm a string. So I think we're okay. Always tough to be sure. All right, but we push that address we're going to create the string at, and then we're done, I think. Now, if this doesn't work, we'll have to explore a little. Okay, we're going to have to explore a little. All right, lldb./string test.out. Although, yeah, I just want to run it and see where it blows up, I guess. Kind of preliminary. Bad access, LDRB. String tests, string EQ. Okay. String tests. If val pushes string address on stack. Okay, that's our only test. String EQ plus 4. That just seems weird. Okay, but maybe our test is not. Well, that sounds like we're not getting where we want to get. Let's break in our word. Sorry, where's eval? Okay, let's put that in. So we're breaking LDRBW3, string test.out, string EQ plus 4. I mean, we're falling apart before we even get to this. All right, let's double check this. Okay, so we evaluate, start the data stack. We get a pointer to this string, L string, quotes, A string, quotes. Okay, so that looks all right. Then we say eval, and eval never gets here. Oh, we didn't initialize our dictionary after all. Eval does need that. I'm so inconsistent. Okay. Okay, so basically I think our test was just not set up right. Okay, now we got a bus there. Yeah, string EQ is probably in the assert equal strings. So I think it maybe, well, I don't know. Oh no, I think that's in the dictionary code. So when it tries to, it runs through the dictionary words to try and see if this is in there, and it doesn't find it. And I think now we're probably somewhere else. Okay, so let's LL again. Break set, let's be my break. And run. Okay, good. We got here. All right, so let's get this up. Well, let's look at X0. Oh, that's not good. Oh, X28. Excuse me, sorry. Yeah, pretty sad when bus error isn't an improvement. Okay, so we got, oh, you know what? I think our test string is in the, no, it's in data. Okay, because he does need to have room to write to it. I'm not sure. All right, let's see. So X28 is pointing to quote a string. All right, so let's just step around. We'll save X0, load the byte, compare. Branch not equal to there. It should just do string X25. X25, X19, what's that? Excuse me, that's our data push. No, right before define string. Data push. X25. Do I have that open still? No. I think this is design notes. X25 is secondary space. Okay, and that's virtual stack pointer. Okay, so push that into there. X25 is secondary space. We haven't initialized that either. Oh man. As you get more realistic, you end up having more stuff in your scenarios, but I don't know. Where does that stuff get initialized? Secondary space. Probably main has to do it. Okay. Oh. That says that should be more public. Well, no, that says it should be somewhere else. I would say compile owns secondary space more than anybody. And then our test can do it. L secondary space compile.o. Oh, that's got to be in main. Okay. Okay, we got progress. Huh. Well, I think we made read word strip away the leading quote, and now we can't use it to identify the word. Oh, these assumptions will kill you. Okay. What is the right thing? Yeah, I'm puzzled. Okay, so I definitely don't need the quotes there for any real stuff, but I think what happened here is we look it up in the dictionary and it's not treated as, well, no, I think something's weird. Yeah, let's find our test. The string is there in the original, so that part's good. Well, actually, the quotes are there, aren't they? Huh. Now that's weird to me because compile not not define string main no REPL. Okay. Um. Oh no, I guess let's start at input. That's kind of the earliest point. All right. Um. We've arranged to skip past this. I mean, read word returns. Sorry, read string skips over that quote because we skip it before we get to x0 or next word. X0 is the return value. So to me, read string, and I think our tests should bear this out, right? Read string, I'm a string with no quotes is the expected value. Now, so one approach would be leave the quotes in there and then strip them out later. Does it update the next word pointer? So I believe read string does that. As it's looping through, it's incrementing next word, and at the end, next word points to the double quote if it exits the loop, So I think basically it points the double quote, and then input gets here and says, oh, well, wait, is that right? I mean, it's saying backup one and put. Oh, right. If we read this, we read the quote, we increment one past it. So when we get here, we're pointing at whatever comes after the quote mark, and we back up one, and that zaps the quote, but we're still pointing to the next character, which is where we want it. So yeah, next word, which almost seems more like next character, but it's pointing to the byte after the double quote mark, and the double quote mark gets zapped with a 0, which in a sense is good. It's just that we lost the knowledge that we have a string here. So this string is what the thing returns as an unquoted string. Now, eval was going to we tried to use the double quote to be a sign that you had it. Okay, so that double quote is not there, so it's never gonna run this check for the data push secondary space line 4647. It's never going to put the string in there. I don't know. I think the I would almost like to make X1 return a type. And it might even be able to take care of the numeric check and let the action be there. So and this is a bit of a redesign, so hang in there with me. I don't know if it's a better or not, but my thought would be read string would come back and say X0 points to the contents of the string. X1 says this one's code 2, which is string. And then eval comes up here and says, okay, instead of me looking for things, I'm going to get code 1 is it's a regular word. Code 2 is it's a string. Code 3 is it's numeric. And if then I just switch on the code instead of switching on the contents of the stuff and looking inside it and all that stuff. So I don't know. Now what I'm not seeing, and this may be bad too, if Al pushes string address, I would have thought that it would say, "Are you a double quote?" No, I'm the first letter of whatever my string contents are. Okay, I'll check for numeric. No, I'm not numeric. Okay, you're a word not found. And then why didn't it run the word not found routine macro? Okay, which I don't know what that does anymore, but we can find that. Nope. Word underscore. Oh, he calls the global word not found handler, which we didn't plug anything in because we weren't expecting to be called. Okay, now I don't know that this is all the best either, but I mean this was so we could substitute things for testing. Let's find this. There should be a declaration somewhere. Oh, there it is. Global word not found handler. Word not found error. Yeah, I'm really shocked it didn't come in here because I think the default is this routine. No, I think it defaults to this is plugged in. If a test overrides it with its own handler, then yeah, that's fine. But now maybe we didn't blow up, so no, it's not a question of blowing up. It's let's walk through and make sure what's going on because that does seem really off to me. If it's, I mean, I can understand why it misidentified it as not being a string, but why didn't it? If it's a known word, it handles it. It should have been an unknown word. Check for string, check for numeric. None of those should be happy. Okay, so let's break here again. Okay, and we'll remember the right one, string tests. Yeah. Okay, so the test compare, the branch not equal should be taken. So step. We expect 3DA4. And it's not. What? Okay, I'm a little lost. X0. So this is saying the character X0 is a double quote. Reg read X0. Well, no, not now. Oh, is that so far off? It's. Oh, I got a memory there. Quote a string. All right. Yes, I'm very puzzled. Okay. So we come in here with the current word. We check it for being a meta word. Well, that certainly should not be true. We should be evaluating. And we're in eval. Okay, we are running that code. Where's this word coming from? BL read word. Do I need a new line after the string? That could be because, well, I don't think we do, but there are situations where we do, and this could be one of them. Variable. String. No, that's not it. Yeah. Well, I think read word comes in, it should read that string, and it doesn't move forward looking for the new line yet. That happens when you start your string read. So I don't think it matters, but it's certainly something I could be wrong on. No, I find it very puzzling because I think this read word, like I'm pretty sure that thing does not return a quote mark. So how the heck is it pointing at the quote mark? I mean, x0, let's make sure x0 input. Okay. X0 is next word, which should be past the quote. All right, we're going to break here. Read string. Okay, skip past the first quote and then return to the second character. And then, I mean, the output is x0 equals pointer to unterminated string. Now, maybe there's something funny there because normally you're finding a space and you zap it with a 0. Here you're finding a quote and you zap it with 0. I don't think that should matter. Okay. Okay, so we'll break it read string. And then I think we can find L exit string and break there when we get there. But yeah, I think that'll get us started. Okay. Are we running string tests? Eval pushes. Okay, that's the only test. Okay, good. Run that. Okay. Why did you not stop at read string? Well, let's break on read word. Eval pushes string address. Make which global? Maybe our string test is not doing something. Read string. It better be global. Read string. Is that only called? I guess it's only called there. No, it should be okay to break at a label. It's only global means it's accessible to other files, but the debugger seems to know when to break at these words. I guess I got to go back to read word though. Breaks it. Oh wait. Yeah, now how does this test not call read word? Okay, so let's look at eval. Oh, it called eval and not REPL. So it didn't read the word. Okay. Oh golly. I think these have to go together to make sense. Okay, so that finds it. All right, so if I do a run, bad access, really early. Okay, let's take our break. I expect it's some sort of initialization error that maybe it's this, but yeah. Awesome Twitch dude, hi. We were just about to start a break. No dark mode, right? So we'll be back in 3 or 4 minutes, but welcome. I'll give an intro then if you're still around. So see you in a few minutes. All right, welcome back. Well, I guess this is why I take breaks. I know it's clear to me, read word is not the right thing to do. We loaded the word into X0 that it needs to evaluate. The problem is we put the word with quotes in, so our code got triggered. But the real read word parser would not return that one. It would return this one. So if I make this else string expected, I think we'll get the error I was expecting. Okay, and then we'll have to deal with it. Okay, word not found a string. Yes, that's what I was expecting. Okay, I feel better. But that sort of reveals well, okay, let's do this. Let's take this one out. Okay, that should be no change. All right. So we're getting that word not found because we've totally gotten out of sync with things. All right. And I think what this does is make me think that the input changes I mentioned would be a good idea. That I think well, no. Yeah, I think the result of this should be x0 and x1 is 0 for a word, 1 for a string, 2 for a number. All right. Now that's not quite what happens here. And I think we need codes to reflect those. So, and I'm just not sure where to put these. REPL.macros, maybe that is the right place. Okay, so let's say equal. Yeah, it's not a string. It doesn't look like a string anymore, but I think that's well, no, I think I had a confusion between what should read word do and what will the interpreter get. And I really wanted read word to take care of those quotes because they're just not useful to me, except eval needed them. And so now I'm questioning whether checking for a quote is the best thing. I think it should just put in a code and just give us that back. Word found is code 0. String found is code 1, and number found is code 2. So I'm suggesting that's what our input should do. So this read string we know we're in a quote here. So I think he should return x1 is string found. Okay, but then we can't use x1 because that's the return value. So I'm going to turn these into W2s. Even this one we're ignoring for now. Okay, and then x1 equals string found code. Okay, so read string, well, I didn't test that right. I probably should check that in here. That's one assert. Let's assert that x1 is 1 first. So no, how can I do this? Okay, because I'm calling BLs, I got to be careful on this. Read word should return x0 and x1. So I need x0 to compare here, but I need x1. So I'm going to need that extra argument. Now I think string tests, no. Yeah, this is the sort of thing. Okay, and LDR at the end. Input tests. Let's use x28. Okay, so at this point, I'm going to move x0 gets x28. And I'm going to check move x1, x0 gets x1, and x1 gets string found. And we should assert equal. Okay, and then this one, we're going to move x28 back. Move x0 gets, and this is backwards. Okay, so we'll save the word pointer. We'll check the string found value first, and then we'll move things back. All right, let me undo this, and we'll make sure the test works. Oh yeah, I forget equate does that. Really? Can I say? Do I say pound? I don't know. That seems weird. I mean, all right. I don't know if I can fix that with this. Right, doesn't like that. Okay. Still doesn't like it. Isn't that how you get a constant in there? Surely we've done that elsewhere. Right, why is that any different? Okay, maybe it just can't be defined that way. What other macros do we have? Well, the other one is we're doing this. I wouldn't call it assembler. All right, let's see a pound define. Where do we put those? Core defines. Okay, core defines is fine. Yeah, I think it's just a weird assembly thing. But this should work. This is more of a Unix just substitution or a C style. I don't know about the pounds. Like I've mentioned before, they seem kind of inconsistent. Now, I don't know if that's the best place for things, but it's certainly shared. Okay, so does that help anybody? Good. Okay, word not found. And where's... Oh, he's blown up before that's an issue. Is this input tests? All right. Yeah, reads whole string. The first assertion failed because we didn't pass through x1. All right. Now x1. Okay, so read word. Okay. So x1 gets set first. Oh, it doesn't. Okay, that test failed because I didn't do it. Good. Maybe we'll get back to TDD here. Okay, so input passes now. Okay, so yeah, where are those? Sorry, I misunderstood your comment. Run mode. I don't get it. I mean, it seems like exactly what we did before. Move flags run mode. Yeah, so what was the issue? Okay. Well, anyway, input. Well, no, no, maybe it is. Let's see where those are. They're in REPL.macros. I don't know. That's where I tried them first. I don't know. I mean, everybody in this section of the app reads core defines as well, but let's go back here. Dot equate word found 0. Okay. Word found. Okay, let's take out the defines. That's just like that. Where's... Oh, let's do string found. Maybe the thing I wanted to look at, it doesn't use REPL.macros, and it was just not available. Okay, core defines, and then number found is 2. Now I'm kind of questioning it because actually 0 and 1 are words. Maybe they don't need to be. All right, now somebody's looking for string found. Who is that? String found. Move x1 string found code. Right. Okay. I think he's probably just not including REPL.macros. Yeah. Okay, kind of a poor message for it, but okay, input first. Yeah. Okay. Right. So normally your return value is an x0. We're saying, oh, there's two return values, x0, x1. It's a little non-standard, but not, I mean, there are definitely programming languages that return multiple values, so I don't think it's too far off things either. But now this one is fine, but these other ones don't do that. Okay, so they need to as well. All right, so x0, that's fine to manipulate. This one, I'm going to move to W2, just like we did the other one. Okay, that should all pass the same. Input tests are the ones we're after. Yeah, okay. Now, okay, so then I think it's in the X1 register and neither a 0 nor a 1. What are you saying is in the X1 register? Our return codes? Oh, the fact that it was, well, nobody's using the fact that read word returns this yet. So I think I want to move this forward to do that. It's got x0. Let's find the test for a regular word. Well, it's still not quite everything I want it to be, but all right. So read line simulates a line read. Okay. Read with a word at the start. Okay, I'm going to clarify this a little. Arrange. Act. And this is the asserts. Okay, so we're basically asserting that that is the same. I don't know if I have this still. Do I? No. It's str x28 sp pound 8. Let me find one and do it right. Yeah, it's sp pound 8. Okay. And then at the end, we load it back in. Okay, so now here, when I get it back, I can hold on to x1, move, well, no, do it here, move x28 equals x1. All right, x0 is found word. Okay, so we're checking that. And then let's check this. Move, this should be word found. He's doing read source 1. Okay, so he's going to find a word. So x0 is x28. That's the found word, found type. Okay, sorry. Oh, thank you. Oh no, it's a store here, isn't it? Oh, no, you're right. Load what we stored. Okay. X20 gets X28. This is the word type. And then we expect word found and assert equal. And this should fail. That's a different one, but the input, there it is. Okay, we don't have that X1. All right, so let's get that on input. Okay, so we'll look for a regular word or number. Okay, so that's the return word. X0 is found word. Sorry, X1. Okay. Now, let's make that. Now that, whoops, he needs macros.REPL. He has REPL.macros. Maybe I need to make sure I'm using the right phrase. Word found, string found, number found. I think I said found word, not word found. Okay. All right, so the input should pass now. Read with word start to asserts. Okay. Now, the consequence of this and it's eval that should get the benefit of it. And I don't think I've totally changed things, but hopefully enough. Okay, so somewhere, okay, we're coming in with the word we read. Word type. Okay, so dictionary search. Well, I think what we can do, I think if the word type is string, then right away we know what to do. We should just push the string and do that all stuff. So I'm going to take advantage of that. I'm going to compare X1 to string found. If it's not equal, I'm going to skip forward to L, check word or number. Okay, but if it is a string, then I'm going to do all this stuff. Now, I don't know if it's the best way to do it, but okay. So now this X0, X28, we don't need it. We don't need this. We don't need this. We've already done our branch. So I think this simplifies nicely. Okay, so if we know it's a string, then treat it like a string. Okay. Okay, so if we look, the thing we get back is a string, then we're just going to do all that. And go. All right. So I think we could make our read routine do this check as well. All right, but okay, so now I'm just going to send him to check for numeric because we already handled string. And in fact, this condition can't happen the way we're doing things. Okay, so I don't know, it's not a real named refactoring, but we've done a refactoring from, we got a result that we would examine further and decide what to do. And instead we're, the result we're getting encodes both the type and the string of it. And based on that, we're sort of doing a kind of a case statement. But right now we don't do numeric, so that's the part that's a little weird. But otherwise, I think it's neutral, except that it will make that test pass now. No, does not. Okay. Let's make sure input is fine. Okay. Eval pushes string address on data stack. Now, I feel like there was something else not initialized, maybe. But let's track through this. So let's break on eval. Oh, we need to set this too. Move x1 is string found. Okay, because we're imitating read word, not calling it. Okay, so string test, now that passes. Do I need to add the quotes back in the test string? No, because the value string test is going to use, we're using this to imitate the results of read word. So read word strips out quotes and sets the type. And so that's what we're doing, is giving it a string with no quotes and a type. And so it should find that address on top of the stack, and then the string should be equal. So that's what it's testing. But I'm I'm eliminating the quotes as early as possible, and I'm using the presence of a quote mark. I'm not using that anymore. I'm just using that type code to say it's a string or number. Okay, and then let's just visually check this. Okay, so where we commit to a word being found, yeah, I guess I would say if, oh, wait a minute. This is still off. Read word. Oh, no, it's okay. Read word has to look for the quote, but once it has it, it's fine. Now, it calls read string. So really, I'm kind of checking my way through the whole thing, because we loop at the front and skip over spaces and all that stuff, read more lines if we need to in the whole bit. But eventually we get down here, well, here or here. First here, if it starts with double quote, we call read string. Otherwise, it doesn't start with a space or a new line or anything. It's a real word. Could be numeric, might not, but it's a word of some sort. Yeah, so the quote check is only read word deciding how should I read this particular word. And the answer is, if it starts with a quote, call read string. A read string will return x0, x1. All paths out that find a word or a number go through here, but the thing is we don't look here to see if it's a number. Okay, so I think that's that's sort of between read word and eval. How should it do that? Today it just checks for numbers or words itself. We could move this call. Yeah, I mean, I could see moving this check into read word and make it return that new code. Okay, not just string found, but number found separately. And then this would be kind of a little case statement at the front, or a series of if else's. I guess you could look at it that way. But a series of simple texts on the type rather than going inside and trying to decide what it is and stuff like that. So, but I think we're at a consistent approach now. All right. Which is good. All right. So now I think, given I'm not going to check, like, what if I don't have a string there, or what if the quote mark is missing, or any of that. That's all an input test. I'm not going to test anything on that. I want to move on. And so runtime string constant, let's say for correct strings. Okay. And then somewhere we need to say, oh yeah, what if strings don't end by, or yeah, I guess that's the only thing that really goes wrong. Okay. So let's say this is done. And it took a little longer than I thought. All right. I'm going to move operator $, which is our print. I'm going to move that up. Okay. Because I think we have just maybe enough time to finish that one. Compile time, that was that more complicated approach I mentioned, and we'll put that together next time. Okay, so this time we want to just get print $ working, and I think we'll just see how we tested print. Let's go to main and find dot. Dot print. Okay, all right. And so let's find IO tests. There may not be one. We've often not. Yeah. Okay, let's get this thing going. All right, this one is dot print string. Standard prolog. Data top x0. Okay, so this thing on top, and we're going to print. I think there's just a print string. And standard epilogue and return. Okay. If you want spaces, I guess you got to put your own spaces in the string. Okay, and main should know about this. And got to validate this being where it should be and make it global. No. What do we call that? IO. Oh, it's just print, isn't it? C-like. Okay. That's the one that prints a string, a zeros terminated string. Okay. And global. Double check. I wasn't very complete about looking at those before because we just had two we were looking for. But let's look in REPL. Okay. Here's the big test. Hello world. Oh. Oh. Why are you not being put on the stack? Word not found, hello world. Well, word not found comes after this. Sorry, let's find the call to eval. Let's make sure the flow gets the right stuff going through. Okay, read word. Oh, does read word pass that through? Whatever is left by read word should be found by eval. Okay, so read word. Once it starts looking for a string, I mean, read string should leave x1 there. Okay, so I don't know. I mean, it sets x0, x1. It does not use them afterwards. And that comes into read word. Read word. We find word start. Okay, so we're finding the first character that's not a blank. We get here. We call read string and exit word. Okay, so somehow the main one is not doing what I expect. Okay, let's... Okay, run. Move after the call to read string. Well, I could, but like read string produces that is the theory. Okay, I'm going to continue to read string. Oh, read word, that's fine. Okay, we'll say hi. I'll be a little shorter since we got to debug through it. Okay, we're in read string. Step, step, step. Okay, now x1 should be 1. Okay, so x1 has the right value. I'm going to step until we hit a return. Okay, reg read x1. Still 1. Okay, I can step out. Find trailing space or new line. Read. What? We just ran read string. Why am I not at exit word? Okay, 2D58. Let's find. Let's read string. Okay, read word. I don't know. Branch to. Well, let's step 290. Store unsigned store byte WZR x22 minus 1. That does look like where it's supposed to be. Okay, let's make sure x1 is still right. Okay, so if I step out, I guess that's just the label it found closest. Okay, so return from read string, and we're going to eval all. Oh, he probably didn't preserve x1. Let's look at eval. Eval all, I mean. Right. Oh, yeah, he definitely didn't preserve it. Okay. So he gets called first, and he's got to decide if we're compile mode and all that stuff and deal with X1 there. But X0 is. X0 is the current word. Well, I think I need both these. Oh, we haven't done this in a while. Yeah, I can definitely change these to X2, but well, that'll help. Okay, but it won't work in compile mode because that is meta destroys X1, so or potentially does. All right, but this does change that. All right, let's save that. I'm hopeful this will work for evaluating. Whoops, let's make REPL. Hello world. Dot dollar. That would be helpful. Ta-da! Okay. All right. That Well, that's good. I think you could probably do something interesting, right? Hello world, 1 plus dot dollar might be hello world. Yeah. Okay. So you can sort of do something now. You could write a loop on, take a string, calculate. I don't know if you can calculate its length. You might be able to get something that grabbed an arbitrary character from it, with the words we have now. So, but I'm happy. I'm glad that's working. All right. So you at least could do print banners and stuff to explain what your numbers mean on your little program. We don't have input yet, but we'll get there. All right. Well, that is good. Compile time string constant. Note we overwrite x1 from read word. I think that'll be a clue to us on Monday. All right. Compile time strings. I think I want to move the operators up. Okay. Yeah. So we'll finish those operations. Well, let's get the compile side working and then finish the operations. Then see what we want to do about fancier questions about strings. And then I think, well, this may be slightly more, well, I don't know. This refactoring, I think we should do having all the features in at that point for a write-only language, no inputs, that does numbers and strings. I mean, that's a nice step forward. It's definitely where BASIC started. Now, the other thing, I'll just give a quick preview. I did finally do some research and found a bunch of, not explanations, but calls. There's TC get adder and TC set adder for like terminal controller. Those let you set raw mode so that each character you type automatically gets read as one input and turns off line editing and all that stuff. Basically, those end up calling IOCTL, which is the Unix level call. And this code, between all these, it gives sample code for doing that. And then also the Apple man page for IOCTL. So I think between those, we will be able to do some sort of input facility. And I don't know, we'll see where it goes from there. But that's I don't know, it looks like a tedious job to track it all down, but it looks like it will work. So that's something. But anyway, that's all right. Well, it's been a good week though. We got variables, strings, variables, arrays, and strings. Well, variables and arrays done, and strings started and sort of done for a runtime version. I'm pretty happy about all that. We've got a few more things to do to get, to get this sort of, at this point, we have everything we need to write programs. And so I would say, in a week, maybe ish, depending how the IO goes, we might be starting to write something. So we'll think about that too. All right. Well, anyway, have a good weekend. Thanks for joining Mudrack 666, especially. You've been very regular here. And see you Monday. Take care. Bye-bye.